Section 5.1, Quadratic Functions. So the graph of a quadratic function is a U-shaped curve called a parabola. It has an extreme value or extreme point called the vertex, which serves as a turning point on the graph. The graph is also symmetric with a vertical line drawn through the vertex called the axis of symmetry. So our vertex, the axis of symmetry passes through that. This function will always have a y-intercept. And as we saw with our toolkit functions, the quadratic has a domain of negative infinity to infinity. Now its range, for this example right here, its range is all y values or outputs greater than or equal to -4. Okay. And this particular function has two x-intercepts, although quadratic functions may not always have two intercepts. They may have 0, 1, or 2. Alright, so determine the vertex, axis of symmetry, zeros, and y-intercept of this parabola. All right, well, first its vertex. The vertex is a point, and I'm going to label it as V of. That is the point 3, 1. So our vertex is the point 3, 1, which means our axis of symmetry is the vertical line x equals 3. Go ahead and draw that. It is a vertical line passing through the vertex. Our zeros, which are our solutions, well, this function actually never crosses the x-axis, so there are none. There are no zeros. And the y-intercept, appears to be this point right here, 0, 7. And that is everything it looks like that we can gather from that graph. Now, there are two forms of quadratic functions. It's of degree 2, so we have an x squared term. And the general form is f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a is not 0, because if a is 0, then it's a linear function. And then there's the standard form or the vertex form. I prefer the phrase vertex form, is f of x equals a times x minus h squared plus k, where a is not 0. Now the vertex is the point hk, which is why I like to call this vertex form, why it is called vertex form most often. Now the vertex is located at h equals negative b divided by 2a. So based on this form here, negative b divided by 2a. Okay, and then the value k, the y-coordinate, or the output of our vertex, is f of negative b over 2a. So we find the x-coordinate first, for the h value, and then we can use the function itself to find the k value if we just are given an equation. So write an equation for the quadratic function g that we are given here in the graph as a transformation of f of x equals x squared. Then expand the formula in simplified terms to write this in the general form, that ax squared plus bx plus c. Alright, so this is going to be a transformation of f of x equals x squared. Let's go ahead and call this g of x. Now we want to write this as a transformation, so this is going to be in the form a parentheses x minus h squared plus k. Now if we can identify the vertex, then we've already found h and k. And it appears this function is shifted to the left 2 and down 3, making our vertex negative 2, negative 3. So evaluating that, replacing those here, we have a, and that will be x minus h, so that will be a plus 2 squared. Remember our transformations, having an x plus h, okay, shifts it to the left, which is exactly what we see here. X plus 2 squared minus 3 because it shifted down 3. We have to find the value a, however. We have to find the value a. So let's pick another point. I'm going to use the y-intercept. Okay, the y-intercept which is the point 0, negative 1. My input is 0, my output is negative 1, which tells me negative 1 equals a times 0 plus 2 squared minus 3. That will simplify. That's 2 squared, so that's 4. So 4a minus 3 equals negative 1. Adding 3 to both sides, we get 4a equals 2, which means a is 2 divided by 4, which is 1/2. All right, so the equation for this is g of x equals 1/2 x plus 2 squared, combining everything we know here, x plus 2 squared minus 3. Now to write this in general form, so this is vertex form. To write it in general form, we need to expand that. So this would be 1/2 times, now x plus 2 squared, x plus 2 times x plus 2, that would be x squared plus 4x plus 4 minus 3. So g of x equals, distributing that, we'll have 1/2 x squared plus 2x plus 2 minus 3. Combining all of that together, 1/2 x squared plus 2x. Then we have a 2 minus 3, so that is minus 1. And that is in general form. Which is what we were asked to do. Now this next question is going in reverse. It says to find the vertex, and then we want to write this in vertex form. A times x minus h squared plus k. However, we are not given a graph. So what we need to do is appeal to those formulas we had earlier. Our vertex is negative b over 2a, comma, f of negative b over 2a. That's how we find our vertex. So in this case, a equals 2, b is negative 6, and c is 7. So to find our vertex, we'll say h equals negative b divided by 2a. That is 6 over 4, or 3/2. All right, so our vertex is 3 over 2. Now we need to find the k value. K is going to require substituting that in, so that's 2 times 3/2 squared minus 6 times 3/2 plus 7. Okay, which is 5 over 2. 5/2, so our vertex is 5/2. So 3 over 2, 5 over 2. Now they want us to write that in vertex form. So we'll have f of x equals, now our a value, we actually know that. We know our a value from that equation. So 2 x minus h, this will be minus 3 over 2 squared plus 5 over 2. And that is our equation in standard or vertex form. All right. Now, the next thing we have is the domain and range of a quadratic function. The domain of any quadratic function is all real numbers, negative infinity to positive infinity as an interval, unless the context presents some restrictions. Okay, that we'll run into some word problems where having negative time or negative something doesn't make any sense, so we might restrict it down to a smaller interval. But the range, okay, in the most general form is written this way. Okay, f of negative b over 2a to infinity, and that should be a parenthesis right there. Or negative infinity to f of negative b over 2a, okay, depending on whether the graph opens up or down. The better way to write that, probably the more understandable, is in our standard form, our vertex form. The value k is either the highest or the lowest value. So our interval is going to be, so in this case, let me just write this. This is k to infinity, and this is negative infinity to k, including k on both ends. So once we find our vertex, that tells us the highest and the lowest point, and therefore, based on which way it opens, opens up or down. That tells us whether it's negative infinity to k or k to a positive infinity. All right, so let's go ahead and find the domain and range of this quadratic function. Negative 5x squared plus 9x minus 1. All right, so we'll find our vertex, and note already that we can tell that our a value is less than 0. That negative 5 is less than 0. That tells us this opens down. So our function looks something like that as a graph. Tells us it opens down. Now let's find our vertex. All right, h equals negative b, negative 9 over 2a. So we have negative 9 divided by 2 times minus 5. That is positive 9/10. I suppose I could have already done this. The domain is all real numbers because there is no context here. All right, negative 5 times 9/10 squared plus 9 times 9/10 plus minus 1 is 61 over 20. Let me go ahead and write out what I did there. Squared plus 9 times 9/10 minus 1, 61 over 20. Now, because our graph opens down, our range begins at negative infinity, and it continues to 61 over 20. And that would be our range, which is what we're looking for. So our domain and range are based entirely on the vertex. Keep that connection in mind. All these things are related in some way, form, or shape. Example 5. A backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She's purchased 80 feet of wire fencing to enclose 3 sides, and she'll use a section of the backyard fence as a 4th side. Find the formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L. And then what dimensions should she make her garden to maximize the enclosed area? To begin with, let's draw a picture. Okay, we need to make sure we have a good idea of what this looks like. Having a good idea of what this looks like will give us some insight. So we've already got existing fencing. All right. Now the sides that are perpendicular have length L. So that is L on the left and L on the right. And we'll just go ahead and call this 3rd side W. Now she's purchased 80 feet of wire fencing. That means that 80 is equal to 2L plus W. If you add those 3 sides up, we should get 80. Equivalently, I'll go ahead and write this as 80 minus 2L. That may be handy in a second. Because the area, this is what part A is asking, is write the formula, is the length times the width. The width is 80 minus 2L. So, our area function in terms of L is 80L minus 2L squared. Or go ahead and rewrite that as negative 2L squared plus 80L. Alright, so there's our area formula. The question is, what dimensions should she make her garden to maximize the area? We are looking for the highest value, the maximum value of the area function there. So what we want to do then is find the vertex. The vertex is either the highest or the lowest. Now if you notice, this function is opening down. So the vertex is going to be the highest point. It must be. So let's go ahead and find h. That would be negative b over 2a. That would be negative 80. And 80, negative 80, or positive 80, is the b value because it's the coefficient on L. Whereas a is negative 2 because that is the coefficient on L squared. So that would be minus 80 divided by minus 4, which is 20. All right. So that is actually my L. Okay. The way this is going to work, my inputs are L and my outputs are area. So what dimension should she make? Well, L should be 20. And my W should be 80 minus 2L, which is 40. Which makes my maximum area, they don't ask us this, but the maximum area is 800. Now these are in feet. Okay, so my length is 20 feet, my width is 20 feet, and my area is feet squared. The question is, what are the dimensions? So let's go ahead and just box these in. Now the area is the 800, so my vertex actually ends up being 2800. Or at least it should be. I'm going to go ahead and check that. Plus 80 times 20. Yes, it is, 800. The context still fits. All right, let's move on to our next question. The unit price of an item affects its supply and demand. That is, if the unit price goes up, the demand for the item will usually decrease. For example, a local newspaper currently has 84,000 subscribers at a quarterly charge of $30. Market research has suggested that if the owners raise the price to $32, they would lose 5,000 subscribers. Assuming that subscriptions are linearly related to price, what price should the newspaper charge for a quarterly subscription to maximize their revenue? Maximizing our revenue, okay, in this context is going to indicate we are looking for the vertex. Okay. Maximizing or minimizing is generally going to come into that. And finding maximums and minimums is a big focus of calculus as well. So if that's where you're headed, this will prepare you very well. Okay, so we're trying to find our vertex. Now we've got these 2 points that if they charge $30, this is our price and our quantity. We have 84,000 subscribers. And they tell us that if they raise the price to $32, that they're going to lose 5,000 subscribers. That would be 79,000 subscribers is what they would have, or they predict. All right, finding an equation between quantity and price is what we're going to be after. Quantity minus, and we'll just go ahead and use that first point. That would be quantity minus 84,000 equals our slope. We need to find the slope between these two as a side step here. 84,000 minus 79,000. 32, switch that, 30 minus 32. All right, so that would be negative 5,000, or 5,000 in loss, divided by negative 2, that is negative 2,500. 100p, p minus 30, because I'm using that first point there. All right, distributing negative 2,500, and that would be 75,000. 75,000. I'm going to go ahead and add 84,000, so that is 159,000, and that is the quantity of subscribers as related to the price. Okay, now we're wanting to maximize their revenue. So all of this was built up to this point. Okay, we want to use this equation. The revenue is going to be equal to, and this is an important thing in business, revenue is the price times the quantity. Let's go ahead and use a capital Q for this. So we can use P times, and our Q value is negative 2,500 P plus 159,000. So that means our revenue function is negative 2,500 P squared plus 159,000 P. What we want to do is maximize that function. Maximizing that function, that has been finding the vertex. Finding our vertex. All right, our h value will be negative b over 2a, so negative 159,000 divided by 2 times negative 2,500. Which is 31.8. All right, now that is a price. That is a price, so that is in dollars. And then we can find the quantity, okay, the maximum revenue. Now they only asked us what price they should charge, so we are done. That is all we need. $31.08 will maximize their revenue. But what we can do is evaluate this, negative 2,500 times 31.8 squared plus 159,000 times 31.8 to give them the maximum revenue. And that would be $2,528,100. The price that we need to attain that revenue is 31.8 per quarterly subscription. All right, our next question is finding the x and y intercepts, okay, of this function, which the y-intercept is simple enough. Y-intercept is finding f of 0. If we input 0 as an input, whatever our output is. So 3 times 0 squared plus 5 times 0 minus 2, which is negative 2. So our y-intercept is the point 0, negative 2. Now our x-intercepts could have 2. We never know. X-intercepts are given by setting that equal to 0. So setting f of x equal to 0. If you notice, this was setting x equal to 0. That is setting f of x equal to 0. So 3x squared plus 5x minus 2 equals 0. And this is going way back to chapter 2. This is actually going to factor. Let's see, we need numbers that multiply by negative 6 that add to be 5. So 1 and 6 to be positive 6, negative 1. Alright, so 3x squared minus x plus 6x minus 2, factoring by grouping, that would be an x, 3x minus 1, factoring out a 2, 3x minus 1. This would mean that 3x minus 1 times x plus 2 equals 0. And the first of those, 3x minus 1, is 0 only when x equals 1/3. And the second, x plus 2, is equal to 0 whenever x equals negative 2. So our x-intercepts are 1/3 0 and negative 2 0. Alright, next we want to find the x-intercepts of this function. Now this one, looking at it, go ahead and factor that. That would be 2 times x squared plus 2x minus 2. Let's see, integers that multiply to be negative 2 that add to be 2. We're not going to find any. Okay, back to the drawing board. It's not going to factor evenly. So what we can do is use the quadratic formula, since all we need to find are x-intercepts. Negative b plus or minus the square root, b squared minus 4ac, all divided by 2a. Alright, a is 2, b is 4, and c is negative 4. In this case, it is in our general form. So negative b, that would be negative 4 plus or minus square root of 4 squared minus 4 times a times c over 2 times 2, because that's our a value. Negative 4 plus or minus the square root of something over 4. Alright. 4 squared is 16. That's going to be plus 32. So this is the square root of 48, which turns out, let's see, 16 is in there, so the square root of 16 is 4. So this is equals minus 4 plus or minus the square root of 16 times 3. That'll make it 4 root 3 divided by 4. So this actually simplifies to be negative 1 plus or minus root 3. So my two solutions, my two x-intercepts, are negative 1 minus root 3, comma 0, and negative 1 plus root 3, comma 0. There are my solutions, or my x-intercepts. Last question. A ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball's height off the ground can be modeled by the equation h of t equals negative 16t squared plus 80t minus, or plus 40. When does the ball reach the maximum height? What is the maximum height of the ball, and when does it hit the ground? So imagine that our function looks like this. The maximum height, or when it reaches the maximum height, is going to be this point right here. Okay. The maximum height is going to be right here. Those both relate to our vertex. That's hk. When does it hit the ground? That is going to be at the points that are our x-intercepts. All right, our x-intercepts is where it hits the ground, and we have our vertex. So our vertex actually answers the first two, and our x-intercepts answers the third one. All right, so to find this, we want to find h, and I'm going to go ahead and set this over here. We're going to find the vertex. All right, so h equals negative b over 2a, negative 80 over 2 times negative 16, 80 over 32, which is 2.5. So the vertex is at 2.5. That is 2.5 seconds. That's how long or when it reaches the maximum height. Now for the maximum height, let's find k. Negative 16, we're evaluating at h, so 2.5 squared plus 80 times 2.5 plus 40. Evaluating that, we get 140. So our vertex is at the point 2.5, 140. Now that is the maximum height, so, and this was all in feet based on our units, so the maximum height is 140 feet. Now when does it hit the ground? We need to solve that equation. So negative 16t squared plus 80t plus 40. I'll set that equal to 0. And we'll go ahead and use the quadratic formula. That will be t equals negative b. I'm going to go ahead and write the equation. Plus or minus the square root b squared minus 4ac divided by 2a. So based on our a value of negative 16, our b value of 80, and our c of 40, negative 80 plus or minus the square root of 80 squared minus 4 times negative 16 times 40, all divided by 2 times negative 16. All right, that simplifies to negative 80 plus or minus, that's negative 32, the square root of 8960. All right, now evaluating each of those, we get these two t values. And we have to round these. Negative 0.458 and 5.458 seconds. Now this is where I said our domain needs to be restricted because we cannot have negative time. Negative time does not make any sense. So when does it hit the ground? That is going to be 5.458 seconds. That is the answer to part C. All right, that brings us to the end of this section. Now there is a lot in this section. We've talked about factoring quite a bit, which that was back in chapter 2. We've talked about different qualities of the quadratic function, or of quadratic functions. Keep in mind certainly how to find the vertex, and that helps you find the maximum. That's the maximum or the minimum depending on which way it opens.